The last topic of chemistry chapter 3, metals and non-metals, that is occurrence of metals and their extraction. So we know that earth is the main source of metals. Seawater also contains some soluble salts of metals like sodium chloride, magnesium chloride, etc. All metals are present in the earth's crust either in the free state or in the form of their compounds. Aluminium is the most abundant metal in Earth's crust. The second most abundant metal is iron, and the third most abundant metal is calcium. The relative abundance by weight of some important metals in Earth's crust is given in one of the table. Where is the table? Where is the table? Where is the table? Hey, we don't have the table here. I don't know why. Anyways, do we have the table before this? No, I don't find that table. Anyways, if I find that table, I'll share with you. Okay, so let's understand what are the states of metal in which they are found in Earth's crust. Native and combined states of metals. The native or free state. A metal is said to occur in a free state when it is found in the crust of the earth in the elementary or uncombined form. This state of metal, when it is found in the uncombined or pure form in earth's crust, is called native state. The metals which are very unreactive, mostly they are very expensive because they are very unreactive, lying at the bottom of the activity series, are found in the free state. They have no tendency to react with oxygen, not attacked by moisture, carbon dioxide of air or any other non-metals. So no oxygen, moisture, carbon dioxide or non-metal can affect them. For example, silver, copper up to some extent, gold, platinum are some examples of such metals. That's the first state in which the metals are found in Earth's crust, native or free state. Very rare, and that's why very expensive. Combined state. A metal is said to occur in a combined state if it is found in nature in form of its compounds. The metals which have a tendency to react with moisture, oxygen, sulfur, halogens, etc., occur in the crust of the earth in the form of their compounds. Okay, what are the compounds? The compounds are oxides, sulfides, halides, silicates, carbonates, nitrates, phosphates, etc. For example, sodium, potassium, calcium, aluminium, magnesium. Very reactive, right? Lying at the top of the reactivity series, and therefore these are never found in the free state. They are always found in the form of their oxides, sulfides, halides. You must be wondering what is halide. So halide is a compound of a metal with a halogen. What is a halogen? Halogen is a fluorine, chlorine, bromine or iodine. So compound of a metal with chlorine, fluorine, bromine or iodine is known as a halide. So metallic oxides, metallic sulfides, metallic halides, metallic silicates, metallic carbonates, metallic nitrates, metallic phosphates. These are some metallic compounds which are found in Earth's crust. And for which metals? For sodium, potassium, calcium, aluminium, magnesium, etc., which are reactive metals. They are never found in free state. The metals in the middle of activity series. For example, zinc, iron, lead. See how they have divided the metals. The metals which are found in combined state, one section of them are at the top of the reactivity series. Sodium, potassium, calcium, aluminium, magnesium. One section of them are in the middle of the reactivity series. zinc, iron, lead, etc. They are moderately reactive. Zinc, iron, lead, etc., which are in the middle of the reactivity series, are moderately reactive. They are formed in Earth's crust mainly as oxides, sulfides, or carbonates. In fact, most of the metals are found in the combined form in the Earth's crust. You will find that the ores of many metals are oxides. This is because oxygen is very reactive element and is very abundant on the earth. So most of these moderately reactive metals are found as or in the combination with oxygen as their metallic oxides. Copper and silver. Copper and silver are metals which occur in the free state as well as in the combined state. Okay, so copper up to some extent can be found in its native or free state. Silver, mostly it is found in its native state, but yeah, these two metals, they also occur in combined state as their sulfides or oxides or nitrates, etc. Let us talk about two new terms, minerals and ores. The natural substances in which metals or their compounds occur either in native state or combined state are called minerals. The natural substances in which metals or their compounds occur either in native or combined state are called minerals. Okay, so in the earth's crust, you are likely to find metals in the form of minerals because minerals are the natural substances. Like, minerals are like rocks. Minerals are like rocks which are found under the surface of earth. So what they do is they dig in with the help of drill, and they find such deposits of minerals under a huge bed of rock. They found the deposit of minerals, and there they do mining, mines. So there they do mining of metals, and they take out this minerals, and from this minerals metals are extracted. That is the process we have to understand. For example, aluminium. Aluminium is at the top of the reactivity series, not like in the top section of the reactivity series. So it does not occur in the form of in its native form. It occurs in the form of its compound, and which is mineral. So it occurs in two forms, two well-known forms, or you can say two well-known minerals. One is bauxite, Al2O3.2H2O, aluminum oxide with two molecules of water of crystallization, bauxite, and clay. Now this clay is not the clay which you are thinking of. Okay, this is name of the mineral of aluminium, which is found very commonly in under the earth's crust. So Al2O3 dot 2 SiO2 dot 2H2O, aluminum oxide. Then there is two molecules of silicon oxide, and two molecules of water of crystallization. So these bauxite and clay are two major minerals from which aluminum is extracted. The minerals are not pure and contain different types of other impurities. The impurities associated with minerals are collectively known as gang. ठीक है, कुछ टीचर्स इसको थोड़े फनी प्रोनाउंसिएशन करते हैं, कुछ लोग इसको गैंगू, गंजू, सॉरी, आई एम सॉरी फॉर दैट। तो ऐसे प्लीज कुछ भी मत बोलो, इसको प्रोनाउंस करने का राइट वे है गैंग। ठीक है, कोई गंगू भाई कुछ भी नहीं है यहाँ पे, ठीक है, गैंग। ओके, सो ये जो इम्प्यूरिटी है उसको गैंग बोलते हैं। Impurities associated with minerals are known as gang or matrix. Yes, you heard it right. Matrix, like as in the movie Matrix. The metals are extracted from their minerals, but metals cannot be extracted from all the minerals conveniently and profitably. The minerals from which the metal can be conveniently and profitably extracted is called an ore. तो चलो अब बात है ओर की. ओर को समझना है ओर. ठीक है, इट इज प्रोनाउंस्ड एज ओर. मिनरल एंड ओर. तो I told you के minerals which are like huge rocks which are extracted with the help of mining, and from the minerals metals are extracted. But you know, all minerals are not useful. There are some minerals which contains less metal and more gang. ठीक है, more less metal and more gang. Metal is less, gang is more. There are some minerals which contain more metals, more metallic component, and less of gang impurity. Okay, gang is less, metal is more. We are interested in the second one, the minerals which contain more metals, more metallic component, and less impurity. ठीक है, from these kind of minerals we extract metals profitably, conveniently, and commercially. तीन चीजें यहां पे जुड़ गई है, प्रॉफिट, कन्वीनियंस एंड कॉमर्स. प्रॉफिट और कॉमर्स एक्चुअली ये दोनों एक दूसरे को कॉम्प्लीमेंट करने वाले वर्ड्स हैं. तो इसका मैं एग्जांपल देता हूं तुम्हें. सपोज तुम्हें दो टाइप के मिनरल मिले. एक मिनरल, सो दोनों का क्वांटिटी है 10 kg. You've got 10 kg of mineral, right? Now in this 10 kg mineral, how much metal is there? The metal is there 2 kg, and 8 kg is impurity. ठीक है, यूजलेस, सिर्फ 2 kg मेटल. 10 kg मिनरल में से सिर्फ 2 kg मेटल मिल रहा है मुझे, 8 kg impurity है. और ये जो दूसरा वाला मिनरल है, it has got 8 kilogram of metal and 2 kilogram of impurity. More metal, less impurity. Which is more better for you? The second one, of course. It has got more metal. It has got less impurity. 80% of the mass is of pure metal. Only 2 kg is impurity, which can be separated. We will see the methods with which the impurities can be separated. Yeah, so I was talking about two kinds of minerals. We are interested in the second kind. And this second kind of mineral, which has got more metal component in it, from which metals can be extracted profitably, conveniently, and commercially, by making more profit, by making it more worthwhile, by making the whole process of extraction of metal more profitable. You choose this kind of mineral, and this mineral is known as ore. O-R-E. I hope you're taking notes. So ore is that mineral from which metals can be extracted profitably, conveniently, and commercially. Now you understand what ore is. So we are interested in ores. Okay, minerals to we understood. Minerals are the substances which contain metals, which are metallic compounds basically. Those are minerals. तो तुम जाओगे कहीं भी और खुदाई करोगे, ठीक है, तुम्हें जो पत्थर कंकड़ मिलेंगे उसमें मिनरल्स होंगे डेफिनेटली. अराउंड अस द अर्थ कंटेन्स लॉट ऑफ मिनरल्स. ये कोई नई बात नहीं है. तुम्हें कोई ना कोई तो मिनरल मिल ही जाएगा, जिसमें आयन होगा या एल्यूमिनियम होगा या फिर कुछ ना कुछ दूसरे सब्सटेंसेस मेटालिक कंपोनेंट्स होंगे. लेकिन सारे मिनरल्स और नहीं होते, क्योंकि सारे मिनरल्स में से मेटल्स को प्रॉफिटेबली एक्सट्रैक्ट करना पॉसिबल नहीं है. Scientists, geologists, and the metallurgists, they do certain kind of research on the land available to them, or on the land according to their you know, tests which they conduct on the surface. And from those tests they determine that whether this soil has more content of iron, more content of phosphorus, more content of magnesium, more content of aluminium, or which metal. Whichever metal is more in content, they assume that beneath in the earth's crust that metal should be present in a larger quantity. Could be, could not be, depends. Like, you know, many places in the interior part of the India, away from the ocean, in the interior region of India, you might have seen, maybe near your native place, your village, the color of the land, the soil is red, reddish. That area or that particular part uh, is believed to be containing more amount of iron. And for the same reason, Mars, the planet Mars, is also red, the red planet. Why? Because it contains lot of iron. So Earth can contain lot of mineral, right? It is not very new for Earth. You, if you dig in Earth and if you find minerals, it's not a very big thing. It can contain mineral, but whether this mineral can give you amount of metal which is necessary to make profit, to get it extracted conveniently, whether it has that quantity of metal or not, that is the question. And that is why we are not interested in minerals. We are interested in specific minerals which has got huge amount or huge component of or huge percentage of metals in them, and those minerals are known as ores. So we are concerned with ores. अब समझ में आ गया ores क्या है? चलो आगे बढ़ते हैं. For example, aluminium occurs in the earth's crust in the form of two minerals, bauxite and clay. अभी मैंने बताया था. Out of these two, aluminium can be conveniently and profitably extracted from bauxite. तो bauxite जो mineral है वो ज्यादा अपीलिंग है, उसमें से एल्यूमिनियम की ज्यादा क्वांटिटी हम इजीली एक्सट्रैक्ट कर सकते हैं. However, it has not been possible to extract aluminium from clay by some easy or cheap method. Therefore, the ore of aluminium is bauxite, although clay is still a mineral. ठीक है, तो bauxite is an ore of aluminium, which is a special mineral from which more aluminium could be taken out. Similarly, the minerals of copper are copper glands. Copper glands means, please note these things down. I will also show you the table, but I want you to note these things down because they are very important. Okay, so bauxite is the ore of aluminium. That's one thing you should note down. Copper glands, copper sulfide, Cu2s, that is a mineral of copper. Cuprite, copper oxide, and copper pyrites, CuFeS2. But copper can be conveniently extracted from copper pyrites. So out of these three, copper glands, cuprite, and copper pyrites, that is CuFeS2, copper iron sulfide. Okay, that's a compound or complex salt, you can call it. Okay, so this complex salt is an ore of copper, right? So all ores are minerals, but all minerals are not ores. This should be very clear by now. From all ores, metals can be extracted profitably and conveniently, but from all minerals, it is not the case. right? So minerals can contain metal. Ores also contain metal, but higher percentage. Types of ores. The most common ores of metals are oxides, sulfides, carbonates, sulfates, and halides. Oxides, sulfides, carbonates, sulfates, halides. These are found very commonly under the Earth's crust. In general, very unreactive metals such as gold, silver, platinum, etc. occur in elemental form or free state. In general, very unreactive metals such as gold, silver, platinum, etc. occur in elemental form or free state. Okay, now see other elements. For example, सोडियम से लेके चलो कॉपर तक समझ लो. They are found in the form of their oxides, sulfides, carbonates, sulfates, and halides. There are some examples which are given over here. The ores, the metals whose ores are found in the form of their oxides are aluminium, copper, and iron. Bauxite is the ore of aluminium. The composition or the formula is given over here. You must memorize this. Cuprite, magnetite, and hematite. Now there is a very little difference between magnetite and hematite. Magnetite is an ore of iron which is generally the iron with magnetic property. That's why the name magnetite. Right? So magnet is made up of the iron which is found in the ore magnetite. Its chemical formula is Fe3O4. And hematite is most commonly found iron ore. It is Fe2O3. Okay. Then there are sulfide ores. So which metal is found in the form of their sulfide ores? Copper, zinc, lead, and mercury. What are their chemical names? Copper pyrites, copper glands, zinc blende, galena, cinnabar. These are the respective names of the ores of the metals. You can say sulfide ores of the metals, and their formulae are given here. Please memorize. Then carbonate ores. Generally, calcium and zinc metals are found in the form of their ores, which are carbonate ores. Name of these ores are limestone and calamine. Halide ores. Sodium, magnesium, calcium, and silver are found in the form of their halide ores. Examples are rock salt, carnallite, fluorspar, horn silver. You must remember these names, the common names of the ores and which metals ore they are and their chemical formulae. Very important. Sulfate ores. Calcium, magnesium, barium, and lead are generally found in the form of their sulfates. And the name of these ores are gypsum, calcium ore. Calcium sulfate is called gypsum. Magnesium sulfate is Epsom salt. Barium sulfate is barytes, and lead sulfate is anglesite. Anglesite. Okay. Okay. Now we have already studied the reactivity series. This is not a new thing for us, right? We have studied this in detail. But how do this reactivity series um, find its application in the topic of extraction of metals? That is very important to know, because if we know where a metal lies in the reactivity series, if we know what is the reactivity of a given metal, then on the basis of that reactivity we can find that how strong a compound will it make with a particular non-metal or a compound. Okay, and if the compound is very stable, very strong with a particular non-metal or an impurity, then to extract that particular metal we have to select or choose, you can say, uh, corresponding required method. And to choose an appropriate corresponding required method depending upon the activity of metal, uh, we must know the position of that metal in the activity series. So the metals at the bottom of the activity series, silver and gold, they are least reactive and they occur in their free state. The metals in the middle of the activity series are moderately reactive and they are found mainly as oxides, sulfides or carbonates. We are talking about these. So zinc, iron, lead, copper, they all occur as their oxides or sulfides or carbonates because they are moderately reactive. But the issue is with the metals at the top of the reactivity series, and we want them in the pure form. Just imagine how much reactive they are, and we just want to extract them into their pure form. How impossible the task will be, but we have to make it easy. Okay, so the metals at the top of the reactivity series are so reactive that they are never found in nature as free elements. They are found as oxides, carbonates, sulfates, halides, etc. Copper and silver are less reactive over here, and copper and silver are also found in the free state as well as in the combined state as their sulfides or oxide ores. So on the basis of reactivity we can group the metals into following categories: metals of low reactivity, silver, gold or copper; metals of medium reactivity, zinc, iron, lead, copper. Zinc, iron, lead, yeah, actually copper and silver, they come together. And metals of high reactivity: potassium, sodium, calcium, magnesium, aluminum. And different techniques are to be used for obtaining metals falling in each category, and that's what we have to study in detail. So here we are with our next topic. The whole thing comes down to the same, um, the concept, that is uh, how understanding reactivity of a metal helps us to extract that metal into its pure form. And this process of extracting pure metals from their ores and then refining them for use is called metallurgy. Metallurgy is the process of extracting metal into their pure form and then refining for use, further refining for use. Because after you extract the metals, it is like 99% pure. But if you want like 99.99% pure metal, then you need to refine also. So this whole process of extracting in pure form and then refining is known as metallurgy. In other words, the process of metallurgy involves extraction of metals from their ores and then refining them for use. The ores generally contain unwanted impurities, gangue, matrix, right? Such as sand, stone, earthy particles, limestone, mica, etc. These are all unwanted particles. We don't want them. And these are called gangue or matrix. The process of metallurgy depends upon the nature of the ore, nature of the metal, nature of the ore, nature of the metal, and the types of impurities present. Therefore, there is not a single method for extraction of all metals. However, most of the metals can be extracted by a general procedure which involves the following steps. So, we will study the general procedure with which all the metals can be extracted. Yeah, there is some difference here and there, but that's what we have to understand. What is the difference and why is the difference? Because of the properties. Various steps involved in metallurgical processes. The following important steps are involved in extraction of metals from their ores. Number one, crushing and grinding of the ore. Crushing and grinding of the ore. So first, ore is basically a mineral in which metal is present in a very high quantity, very high percentage. This ore is not present in the form of powder, or you can say ready-made metal pieces. No, This ore is present in the form of huge chunks of rocks, so huge that you can say they cannot even be lifted by 10 people. They have to be lifted by huge cranes. So such an ore which is of this huge size of a huge you can say uh, boulder, okay, size of a boulder, cannot be directly converted into metal. First, it has to be broken down into small pieces. Without breaking down, how can you convert it into metal? So that process of crushing and grinding is the first process. Whether it is a small stone, medium sized stone, huge stone, or a boulder, you have to crush them all and make them powdery. Making them powdery, crushing them, makes the further process of extraction easier. So what is the first step involved in the metallurgical process? For any ore, you need to crush and grind the ore. Right? Huge pieces of rocks will not give you metals easily, will make your further processes more difficult. We have seen that for any chemical reaction to occur, and chemical reaction are going to occur, metals cannot be extracted from their ores by just physical means. We have to do some chemical processes. For doing chemical processes on the ores to extract metals, we have to make sure that they react. And for reaction, for chemical reaction, one of the most important characteristic which we studied in the first chapter is there should be a large enough surface area. If the surface area is huge, if there is a large surface area, then the extraction process becomes easier. Correct? Then the extraction becomes easier. If the ore itself is in huge chunks of rocks, it cannot react and then it cannot be extracted. So the first process is crushing and grinding. We will discuss all these steps in appropriate details. Okay, so don't worry about it. I'm just saying what I feel like or what I know about it, so that you have a proper idea before we start studying this topic. Second step in the process of metallurgy is enrichment of the ore or concentration of the ore. Now, what do you mean by enrichment or concentration? They mean a very, you can say, interesting thing. Enrichment or concentration means now after crushing and grinding, we do certain, typical things with this powder, which we have now got, powdery substance. We can do gravity separation with them. Gravity separation means they are put on a belt, a conveyor belt, and this conveyor belt is moved at a great speed, high speed, and the ore, which is now basically impurity and metal both mixed in powdered form, they are allowed to fall far away from the belt with their momentum. Now, since metal particles are heavy and they've got more inertia, they will fall near the belt, and the non-metallic particle, dust particle, soil particles, all the light particles, they will fall far away or they will just fly away. So what happens is, in this gravity separation, gravity pulls the heavy particle, and metal particles being heavy, they always fall near the conveyor belt. So that's how you separate metallic particles and non-metallic particles. First, or one option of enrichment or concentration of ore. One more option we have in enrichment or concentration of ore is you can do magnetic separation. If the ore is magnetite, if it is made up of iron, even hematite, yeah, that also gets attracted by iron. So you can on the conveyor belt where there is uh, you can put a huge electromagnet near the conveyor belt. All the metallic particles from the ore will get stick to it, and all the non-metallic particles will remain on the conveyor belt, and so we can separate metallic and non-metallic particles. We are concerned with metallic particles, so ore still not in pure form, but ore which has got huge percentage of metal will be separated from absolutely non-metallic particles. So this can also be an enrichment or concentration process for the ore to become more and more pure. Basically, extraction has not happened, but what we are doing is we are cleaning it of the non-metallic impurity. Third enrichment process is froth flotation. Froth flotation is a very amazing process in which the huge tank, in that huge tank, this ore powdered ore is put, and there is oil and water mixture in that, and air is blown into that tank with the help of huge pipes. So there is constant agitation or stirring of that mixture of mixture of water, oil, and ore, constantly stirred and agitated. And this, what happens, it forms this kind of froth, that is झाग बोलते हैं ना उसको हिंदी में, ठीक है, ऐसे झाग जैसा फ्रॉथ जैसा बन जाता है. So this froth, what it does is it attracts, or it sticks to the metallic particles. Now, since froth is lighter, and oil, which is part of the mixture in that tank, oil and froth starts to float at the top of that container, at the top of the tank, and the non-metallic particle do not stick with this froth. They settle down, they are heavy. Okay, so these metal particle being heavy also, they float because the oil and the froth has stuck to them, and the oil and froth is lighter than water. So all the metallic particle come to the surface, and they are just taken out, tapped out of that container, of that huge tank. So that is froth flotation. Okay, so these are few steps by which enrichment of ore is carried out. Then extraction of metals from concentrated ore. Now we have got concentrated ore. Extraction can have different steps, methodology. It can be electrolytic extraction. Directly you can do electrolysis of the ore, or it can be simple oxidation, a simple reduction, where you can directly reduce the ore to get their pure form, to reduce them from their oxides, or you can do roasting or calcination. These are specific processes of you can say extraction of metals, kind of reduction only, but both are done in different conditions, roasting and calcination. So that is extraction of metal. Now you've got pure metal, but not 100% pure. So last step, the fourth step, is refining or purification of impure metal, and that has to be done with the help of electrolysis. Okay, so we'll also understand what is electrolysis in this step. So let me just give you a few glimpse of these steps involved in metallurgy, which I already talked about, or which I already spoken about in just now before reading this. But still, I have to read because you need to write answers from your textbook. So as I told you, crushing and grinding, because ores are present in nature as big rocks, so they are to be broken into smaller pieces with the help of crushers. So these crushers are also having different names. They are having like the names of these crushers are big jaw crushers, or ball mill ball mill grinders, big jaw crushers or ball mill grinders. If you go to YouTube and check the videos of big jaw crushers or ball mill grinders or crushing and grinding ore, if you just type that much, you will find many videos, many useful videos, just for your knowledge. Because see, what you're doing is you are imagining things right now, and that is a beautiful thing. You have to have an imagination. Like, we see so many online platforms giving you cutting edge technology, animation, and everything. They serve you on a silver platter. so that you don't have to imagine everything. You just see the animation and you understand. But I think that's a very bad way, because that is killing your imagination. What I'm doing is I'm acting as a audiobook to you. You know, audiobook are a thing right now, right? So audiobook, what does it do? It just reads out the story for you, or whatever the book is there. It just reads out. So you have to close your eyes. Your eyes will not have any strain. It is just like someone is conversing with you, and this is just like a conversation. This lecture is just like a conversation with you. So you can understand that, you know, how these things are done, and you have to imagine also with that. I'm not giving you any pictures. Yeah, if there are any pictures, I'm definitely giving you. In between, I show you videos also. But at times, you need to use your imaginations, because things are very simple, right? Like I'm telling you, big rocks has to be broken down or crushed or grinded into fine powder, small pieces. So it's not a big thing to imagine. It's a very small thing. Yeah, if you want to exactly see what is done, go to YouTube. Check out what are big jaw crushers, what is ball mill grinder, what is a crushing and grinding of ore process. They will show you, and you will have an accurate idea. Right now, I think we should focus on our chalk and talk method. That is, I'll highlight a few points, I'll give you information, you visualize, and you can frame answers. So I'm just giving you information which is required, which is academically required, which is required as per your board exams, right? As per your syllabus, as per your CBSE board. That's what we should focus on. Okay. Uh, Enrichment of the ore. I told you about three process of enrichment: gravity separation, magnetic separation, and the third one was froth flotation. Correct? So, ores are usually found mixed up with large amount of impurities such as soil, sand, clay, rocky materials known as gangue. These unwanted impurities have to be removed before extracting the metals. So, process of removal of unwanted impurities from the ore is called enrichment or ore concentration. So, before the ore is subjected to metallurgical processes for the extraction of metals from the ore, it is essential to concentrate the ore. The processes used for removing the gangue from the ore are based on differences between the physical and chemical properties of gangue and ore. Different separation methods are used, which are discussed in higher classes. So they are not discussing anything, but yeah, here some things are given. Let me read it for you. Different techniques for separation of ore and gangue particles. First is hydraulic washing or washing with water. So based upon difference in the densities of ore particles and impurities used for ores of iron, tin, lead, etc. So basically, what they do is they just uh, pass the ore under the pressurized water jets. So water streams which are thrown at a high pressure onto a surface, the ores are just passed under it. So what happens is, in this washing, hydraulic washing, the lighter particles are just washed away. The heavier particles remain behind, and you get your metallic particles enriched. Froth flotation, I told you, based on the principle of difference in wetting properties of the ore. I told you metals are wetted effectively by froth, that is the foam, basically. Yeah, so that froth floats above the surface of water with the help of oil, and it is tapped out. Gangue particles, they go down. Used for sulfide ores of copper, zinc, lead, etc. Magnetic separation, based on difference in the magnetic properties of ore and gangue. Used for hematite ore of an iron. Chemical methods, this is the fourth method. uh, Based on the difference in some chemical properties of metals and the impurities, used for aluminium. Okay, so we will discuss them in higher classes. For now, you have enough information. Now we come to our main process, that is extraction of metal from concentrated ore. The metal is extracted from the concentrated ore by the following steps. First, we convert concentrated ore into oxide. Always remember, we must convert any of the ore, whatever ore that is, we must convert it into its oxide. The production of metal from the concentrated ore mainly involves reduction process, but it is easier to reduce metallic oxides than metallic sulfides and carbonates. Therefore, before reduction can be done, the metal sulfides or carbonates must be converted into metal oxides. Okay, so let me give you a chart. So we have metallic sulfides and carbonates. We have metallic sulfides and carbonates. These metallic sulfides and carbonates collectively, by different processes of course, but are to be converted into metallic oxides. These metallic oxides are to be reduced and converted into metals, pure metals, but not 100% pure, maybe around 99% pure. These 99% pure metals are to be refined. Okay, so this refining is known as electrolytic refining, electrolytic refining, and we get the result as 100% pure metals, right? So the steps which were before these were what? Before these we did enrichment or concentration of ore. Before that we did uh, hey before that one second. Yeah, before that I think it was crushing, enrichment, and the extraction. Okay, after in the extraction process, if we have got sulfides and carbonates, they are to be converted in metallic oxides. If we directly get oxides, then reduction, then we get 99% pure metal, then refining by electrolytic refining, and then pure metal. That is the whole thing, whole story I told you in short. Okay, let's talk about this. Okay, so the metal is extracted from the concentrated ore by the following steps. Conversion of concentrated ore into oxides. The production of a metal from the concentrated ore mainly involves reduction process, and I told you about this earlier. But it is easy to reduce metallic oxides by reduction than metallic sulfides or carbonates. Therefore, before reduction can be done, metallic sulfides or carbonates must be converted into metallic oxides. And this can be usually done by two processes which are known as calcination and roasting, which I talked about earlier. So these are two processes which can convert metallic sulfides and metallic carbonates into their respective metallic oxides. The method depends upon the nature of the ore. Whether you will use calcination or you will use roasting depends on the nature of the ore. Carbonate ore is converted into oxide by calcination. Always remember. इसको तो याद करना है, ये सारी इंफॉर्मेशन है, लर्न कर लो, बहुत अच्छा होगा. प्लीज लर्न इट. ओके, इसमें कोई दूसरा ऑप्शन नहीं है तुम्हारे पास. ऐसा कोई मैं तुम्हें निमोनिक या ऐसा शॉर्टकट नहीं दे सकता, बिकॉज दिस इज लाइक अ फुल इंफॉर्मेशन आई एम गिविंग. यू मस्ट रिमेंबर ऑल दिस इंफॉर्मेशन, तो ही आंसर लिख पाओगे. ऑलराइट. So, a carbonate ore is converted into oxide by calcination, while a sulfide ore is converted into oxide by roasting. Sulfide ore is converted into oxide by roasting, and carbonate ore is converted into oxide by calcination. Remember this. Okay, let's study the conversion of oxide to metal by reduction process. Hey, wait. Before that, we must understand the conversion of ore into metal oxide. So we are going to study calcination first. Calcination is the process of heating concentrated ore in the absence of air. That is the definition of calcination. Heating concentrated ore in absence of air. Absence of air में जब heat करते हो तो क्या होता है ये? Calcination. Remember that. The calcination process is used for following changes: to convert carbonate ores into metal oxide, to remove water from hydrated ores, to remove volatile impurities which can be heated and get converted into steam, or you can say vapors very easily. To remove them from the ore, we use calcination. For example, and this is very important because we are going to study the example of calcination. Zinc occurs as zinc carbonate in calamine, zinc carbonate ore. The ore is calcined, that is, heated strongly in the absence of air to convert it into zinc oxide. During calcination, carbon dioxide is expelled. During calcination, carbon dioxide is expelled. So, zinc carbonate, which is zinc ore, calamine ore, you can call it, it is subjected to calcination, that is, it is heated strongly in the absence of air and it gets converted into zinc oxide, which we needed, and carbon dioxide is evolved. Similarly, siderite or iron carbonate, ferrous carbonate, you can call it, that is also subjected to calcination to get converted into iron 2 oxide, and carbon dioxide is expelled. So heating in the absence of air. Heating in the absence of air is calcination. Okay, calcination is generally done on carbonate ores. Roasting is generally done on sulfide ores. So we are talking about roasting now. People have a completely different meaning of this word now, since you can say this was not the case earlier. This is only since last, you can say, 4 to 5 years, roasting has got a new meaning and now it is very famous. Everybody knows what's roasting. हम भी करते हैं, हमारे लाइव क्लास में रोस्टिंग करते हैं, बिल्कुल करते हैं, ठीक है. So roasting is heating a concentrated ore strongly in the presence of excess air. ठीक है. ये जो एक्सेस एयर है ना, उसका मतलब है तुम्हारे दूसरे क्लासमेट्स. हीटिंग स्ट्रांगली का मतलब तो अब तुम जान ही गए होगे. हीटिंग स्ट्रांगली. अच्छा, ये जो कॉन्सेंट्रेटेड ओर है, रीड इट एज जिद्दी स्टूडेंट. ठीक है. हीटिंग स्ट्रांगली और बीटिंग स्ट्रांगली, अ जिद्दी स्टूडेंट इन द प्रेजेंस ऑफ होल क्लास इज रोस्टिंग. ठीक है. नॉट बीटिंग फिजिकली. प्लीज, मैं ये सब नहीं करता. अपने लिए शब्द ही काफी है. शब्द का पावर. ठीक है. ठीक. It is the process of roasting is the process of heating the concentrated ore strongly in the presence of excess air. This process is used for converting sulfide ores into metal oxides. In this process, the following changes takes place. The sulfide ores undergo oxidation to their oxide. ठीक है. In the presence of air, if concentrated ore, sulfide ore is heated, it becomes oxide. Moisture is removed, volatile impurities are removed. For example, zinc blend, zinc sulfide, वो पहले जो था वो zinc carbonate था, ये sulfide है. Zinc sulfide, zinc blend ore is roasted, that is, in the presence of air, it is strongly heated and gets converted into zinc oxide, and sulfur dioxide is evolved. In calcination, which gas was evolved? Carbon dioxide. That is the difference. Next example is iron pyrites. Heated in the presence of air, strongly ferric oxide is obtained and sulfur dioxide is evolved. Ferrous oxide, heated more strongly, gets converted into ferric oxide, which is much more easier to reduce. Okay. If the ferrous oxide is not converted to ferric oxide, it would combine with impurities present and form slag. So this slag, the word slag means the impurities of silicate. silicate impurities which are difficult to remove. Okay, so ferrous oxide has to be converted into ferric oxide, and only then it is reduced. So the differences between calcination and roasting are given over here. I recommend that you go through these processes, whatever is written over here. You go through these processes and you pause the video, go through them and note them down. I'm not going to read them for you. Okay, I'm not going to read them for you. You need to note down the differences because this is important. Pause the video, note them down, please. Okay, let's go ahead. Conversion of metal oxide to metal. Now we are at the second last stage, you can say third last or second last. Yeah, the metal oxides formed after calcination or roasting is converted into metal by reduction, and everybody knows what is reduction. Reduction is removal of oxygen. The method used for reduction of metal oxide depends upon the nature and chemical reactivity of metal. See, some metal oxide like aluminum oxide cannot be reduced by using normal reducing agents. They have to be electrolytically reduced, that is reduced by electrolysis. But the oxides of zinc, oxides of iron, oxides of copper, these oxides which are like moderately reactive, they can be reduced easily by some reducing agents like hydrogen or carbon monoxide, etc. So metals are grouped into three categories: low reactivity, medium reactivity, high reactivity. So what are the steps of reduction? Low reactivity, like mercuric sulfide or mercuric oxide. Mercuric sulfide, when it is roasted, it gets converted into mercuric oxide, and sulfur dioxide is evolved. This mercuric sulfide is known as cinnabar ore. Okay? So first we heat it in the presence of oxygen, that is roasting, and the oxide of mercury which is obtained, it is simply heated. Simply, सिर्फ हीट करना है, रिडक्शन कुछ करना ही नहीं है. सिर्फ हीट करोगे ना तो mercuric oxide will get converted into mercury metal. That's it, liquid mercury मिल जाएगा. Just imagine, low in reactivity series कितने sorted होते हैं, simple होते हैं यार. कॉपर सल्फाइड है तुम्हारे पास, कॉपर ग्लैंस, उसको हीट करो इन द प्रेजेंस ऑफ ऑक्सीजन, रोस्ट करो उसको, कॉपर ऑक्साइड मिलेगा. दिस कॉपर ऑक्साइड when it is heated with copper sulfide, again more of copper sulfide, it gives you copper and sulfur dioxide. ठीक है, तो मतलब इसको सिर्फ हीट करते जाना, हीट करते 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 you will get copper. Middle of the reactivity series, chemical reduction. See, the metals in the middle of the reactivity series such as iron, zinc, lead, copper are moderately reactive. फिर से copper का नाम ले रहे वो लोग, और lead का भी नाम लिया है. lead पहले नहीं था ना, mercury था. हाँ, copper का भी नाम लिया है, बट ठीक है, पढ़ लेते हैं एक बार. तो ये जो moderately reactive metals है, which occur in the form of their sulfides or carbonates. So these sulfides and carbonates are to be converted into oxide by roasting or calcination. The oxides of these metals cannot be reduced by heating alone, as in the case of we just saw which one we saw, mercury and sulfur. I'm sorry, copper. I'm sorry, copper. So these metal oxides are reduced to free metal by using reducing agents like carbon, aluminum, sodium, calcium. These are all reducing agents. Reduction with carbon. The oxides of moderately reactive metals occurring in the middle of reactivity series like zinc, copper, nickel, tin, lead can be reduced by using carbon as reducing agent. In the process, metallic oxide is mixed with coke. You know what is coke? Coke is not at all Coca-Cola. Okay, coke is 99.9% pure carbon. Okay, so they are heated with this coke or carbon, which acts as a reducing agent, and they give out pure metal with carbon monoxide. Okay, so that is the case more or less with iron or lead oxide also. They are heated with reducing agents and they give out pure metal and carbon dioxide or carbon monoxide. So coke is very commonly used as reducing agent because it is cheap. Okay, it is used in the reduction of oxides of copper, iron, tin, etc. However, coke cannot be used for the reduction of oxides of more reactive metals like sodium, potassium, calcium, magnesium, aluminium, manganese, etc. One disadvantage of using carbon as reducing agent is that small traces of carbon are added to metals as impurity. Therefore, it contaminates the metals. मतलब कार्बन इजी तो है, चीप तो है, इसको यूज कर सकते हैं एक्सट्रैक्शन के लिए, बट it also gets added to the metal as impurity, which is unwanted. Then there is another method of reduction, that is using carbon monoxide. Carbon monoxide also is a good reducing agent. So if you reduce the oxides of metal with carbon monoxide in the furnace, for example, iron oxide, ferric oxide, it is treated with carbon monoxide and heated to give pure iron and carbon dioxide. Aluminium can also be used as a reducing agent. Certain metal oxides are reduced by aluminium to metals. This method is known as aluminothermy or thermite process. I'm going to talk about and I'm going to show you a few things which are super. I will show you. Wait. Aluminothermy or thermite process, where aluminium is used as a reducing agent. ठीक है, for example, chromium, manganese, titanium, vanadium metals are obtained by the reduction of their oxides with aluminium powder. So initially we started with coke, right, for reduction. No, initially we started with just heating, plain heating. Then we said that for some moderately reactive metal, strong heating does not work. So we have to use some reducing agents. For example, we used carbon, that is coke. Then we use carbon monoxide. Now we are using aluminium powder. And this process is known as aluminothermy or thermite process. For example, manganese dioxide is heated with aluminium powder and manganese is obtained. Manganese dioxide heated with aluminium to form manganese and aluminium oxide. Similarly, chromium oxide is treated with aluminium, heated with aluminium to form chromium and aluminium oxide. It may be noted that aluminium is an expensive metal and therefore it is not used to reduce metals which are less expensive than aluminium. Aluminium is not expensive, aluminium is cheap. Why they are saying aluminium is expensive? Aluminium is very cheap. कुछ भी बोल रहे हो. Okay, before we go ahead, I want to show you something as I promised. Wait. Okay, so I was talking about aluminothermy or thermite process. Okay, now this thermite process is generally an exothermic process. In this process, when aluminum is used to extract oxygen from any metallic oxide, this process gives out a lot of heat, and generally it is used for welding the pieces of iron together by heating them. It forms so much of heat that the pieces of iron which are you can say extracted, or you can say iron oxide which is extracted into its pure form, that is iron, it melts when it is when the extraction process ends because of this highly exothermic reaction. So I have a couple of videos to show you. One video is the application of this aluminothermy or thermite process, where I'm going to show you thermite welding. Okay, so this thermite welding, let me tell you, it is used for railroads. Railroad means your railway track. तो रेलवे ट्रैक पे तुम्हें पता है ना मेगा ब्लॉक होता है, तो ये सब क्या होता है मेगा ब्लॉक? मेगा ब्लॉक मतलब वो जो रेलवे ट्रैक है उसको रिपेयर करने का काम चलता है, और बहुत बार ऐसा होता है द रेलवे ट्रैक डेवलप्स क्रैक्स at you know at some places on the railway track. There are some cracks, and these cracks are to be taken care of, otherwise it can cause huge accidents. So they examine in a week or so, or on regular intervals of time, they examine these cracks and they fill the cracks, or they weld these tracks together with the help of aluminothermy or thermite welding. Now it is not possible to कि एक ट्रैक पे क्रैक आया छोटा सा तो उसको रिप्लेस करके नया ट्रैक लाओ. It's a huge weight of that iron track. Steel tracks, railway tracks are huge, heavy. They cannot be replaced so easily. So they can be welded and they will become as good as new. So how this welding is done and how dangerous this process is, because of this thermite process, which is you can say highly exothermic. It produces a lot of heat. Let's see how dangerous it is. Okay, so I hope you're watching this. Yeah. So as you can see, this thing which you are watching here, this is a kind of a mold, okay, which is made over the place at which there has been a crack developed between the two pieces of between not between two pieces, but in a track, in an iron or steel rail track. Wherever there is a crack developed, they make this kind of mold. They hold it tight together, the cracked part of the track, and they put this container which you see in this guy's hand. वहां के वर्कर भी डूड है भाई. वर्कर को भी टैटू वैटू, उसका बॉडी देखो, उसके पास गैजेट्स देखो, और इंडिया के वर्कर देखो बेचारे, एकदम मतलब क्या बोलेंगे यार. ठीक है, चलो देखते हैं. Cool. So you see this, the whole container. This is in this container. This thermite reaction will happen. And iron powder, iron oxide powder is already present inside. ठीक है, यहाँ पे वो लोग एल्यूमिनियम को डालेंगे और थोड़ा सा उसको फायर देंगे, हीट देंगे, एंड द रिएक्शन विल प्रोसीड ऑन इट्स ओन. और नीचे से एल्यूमिनियम मेल्ट होके निकलेगा. ये बकेट जो दिख रहा है ना तुम्हें, उसमें नीचे होल है, तो वो एल्यूमिनियम सीधा इसके अंदर जाएगा और ये जो रेलवे ट्रैक पे जो क्रैक्स है उसको फिल कर देगा. देखो, ये डाल दिया. अब दूर हट जाएंगे बिकॉज इट्स हाईली एक्सोथर्मिक, एज आई टोल्ड यू. दूर दूर हट गया. जस्ट सी द हीट, अमाउंट ऑफ हीट विच इज. अभी तो शुरुआत है, ये तो शुरुआत है. अभी तो हीट देखो कितनी आएगी. ये देखो, देखो नीचे से देखो, यू सी दैट जलने लगा है. ये देखो, दिस लावा, निकला लावा. दिस इज योर मोल्टन आयन. ये नीचे से सीधा निकल गया मोल्टन आयन. ठीक है, अभी मोल्टन आयन ना, ये जो कप्स दिख रहे हैं, वो कप से इधर होल है, उसके अंदर डायरेक्टली जाएगा. ये देखो, उससे अंदर से डायरेक्टली जाए. ये पूरा भर गया लावा से. अब ये ट्रैक का जो क्रैक है वो भी भर गया. अब देखो, ये धीरे धीरे इसको डिसेंबल कर देंगे. कितना केयरफुल रहना पड़ता है देखो. दीज पीपल, दे आर नॉट टॉकिंग मैन. दे आर जस्ट सिंपली साइलेंटली डूइंग देयर जॉब. साइलेंटली, कुछ बात नहीं, कुछ मच मच नहीं, कुछ नहीं, साइलेंटली अपना काम कर रहे. देखो, सुपर है यार ये. Now they're wearing gloves because see, inside hot stuff. See this. This is molten iron, which is settled actually in the crack. ये extra molten iron है उसको लोग तोड़ तोड़ के निकाल रहे हैं. You see that? It has filled the crack completely. So that is due to aluminothermy, thermite welding. सिर्फ रेलवे ट्रैक्स को वेल्ड करने के लिए नहीं है, जो बड़े बड़े गर्डर्स होते हैं जिसके ऊपर तुम्हारा जो जैसे तुम्हारा मेट्रो का ब्रिज है, वो ब्रिज के दो पिलर्स के बीच में जो गर्डर है ना, उसमें भी ऐसे मेटालिक पीसेस होते हैं, बड़े बड़े क्रेन्स में होते हैं. वो सबको वेल्ड करने के लिए थर्माइट वेल्डिंग का यूज होता है. नॉर्मल वेल्डिंग विल नॉट डू दे. नॉर्मल वेल्डिंग से तो वो इतना लोड नहीं ले पाएगा. थर्माइट वेल्डिंग चाहिए वहां पे. अब उसको पूरा पॉलिश कर देंगे तो वो ट्रैक पूरा एज गुड एज न्यू बन जाएगा. I think this is from Scandinavia.
I catch the eye of my ideal customers at the right time. I can connect with someone like.
ठीक है. So let's have a look at one more video which I have found for you. Thermite reaction gone bad. तो ये एक वीडियो है जहाँ पे क्लासरूम में थर्माइट रिएक्शन कर रहे एक प्रोफेसर. I think this is going to be good. Let's see. Cool. Okay. So yeah, we find out what is thermite welding. I hope you like that. All right. Now, what about the extraction of metals which are high up in the reactivity series? And they are reduced by electrolytic reduction or electrolysis. Okay, let me see whether this part is going to. Okay, when we have purification. Okay, so I think I require, because there is corrosion and all, so I require one more lecture, and I'm going to start in that lecture from you can say extraction of metals high up in reactivity series or reduction by electrolysis or electrolytic reduction. So for now, I'm not giving you any homework. Let me finish that last part. I thought I would finish it today, but yeah, this is becoming a lot because there is so much of information which I cannot give in a single video. I can, but I don't want to, because it becomes too long and it's pointless for you to just stare at the screen for so long. Okay, so yeah, little by little, we can watch and finish it. Okay, so I'll see you in the next video. Till then, bye bye.